for measuring single and double film on silicon and other substrates. This system comprises of a helium neon laser on the left hand side of this unit. There is a polarizer prism and a quarter wave compensation plate in the front, and on the right hand side it is an analyzer. Both these arms, the angles can be changed, the incident angle, which is called phi, and currently this angle is set at 70. It can be decreased to 60 or increased to 80 and 90. During normal operation, all silicon dioxide wafers can be tested using a 70 degrees angle. The analyzer arm also should be at 70 degrees, and there is a photomultiplier tube detector on the right hand side. Or there could be a silicon photo detector also. So normally, in order to test the system, the sample table should be aligned first. There is an Allen screw at the bottom of this big dial wheel here. The Allen screw should be loosened, and then by rotating this knob, the table can be lifted up and down, and precision alignment of the sample can be made using the viewport here by sliding to locate it to the correct location where the film is to be measured. Also, this arm is called an autocollimator, and there is a light source inside this autocollimator, and which generates a dot, a bright dot on a crosshair which is centered across the x-axis and y-axis. The bright dot can be moved to the center of the crosshair by adjusting two tilt knobs on left hand side and the right hand side under the table, and there is also another knob on the rear side of the table that will move the dot along y-axis. The dot will move along x-axis by these left hand and right hand tilt knobs. Also, it is important to make sure after loading a sample, the beam, the laser beam, should be reflected off the sample, and it should be passing through the aperture on the analyzer arm. You can see the dot. That's the helium neon laser. So in case if the sample height is not proper, then the dot won't be at the center of the aperture. So then it calls for sample alignment again. So soon after power up, the system will prompt up compensator insert. So then there is a slide arm here. You have to push it up and then press continue. The operation of the ellipsometer is from the keypad here. So you have buttons for program selection. At any point of time, to halt the process, we can use the halt button, and then the reset is to reinitialize the whole system. And the continue button is to be used whenever the display prompts. So at this moment, it says down compensator press, and then press continue or program. So I'm going to select a program, and this program 210, I'm selecting this program as per the Rudolph standard procedure, where the measurement routine is 2 and calculation routine is 10, and hence 210. The program code could be a 6-digit code where the last 3 digits are used for print format. The details are given in the user manual. So once you press 210, we have to press letter E on the keyboard to enter. So the letter C is for cancelling, and D is to be entered whenever there is a decimal point to be entered. So this routine 210 measures the refractive index of the sample, whose thickness is about 1000 angstrom units. Also, it will measure the film thickness. So the light beam is polarized using the polarizer crystal here, and then the compensator plate does the linear polarization of the beam. At this moment, there are motors spinning the polarizer crystal and analyzer crystal during the calculations of delta and psi. Now, the calculated refractive index is 1.464, which tallies with the standard value. And the order thickness, which is 2818 here, is evaluated using the constant factors of refractive index and beam extinction ratio in the film. So the thickness displayed here is 1174 angstroms. There is yet another program. The number is 211, and you press enter, and now the system prompts to enter the local film refractive index. I'm entering 1D462, which is 1.462, and press enter. So in this program routine, we are entering the refractive index value. The system has a built-in thermal printer, and which prints at the end of every calculation routine, and it will print the program number, the delta value and psi value, and refractive index, the thickness of the layer, and also order thickness of the layer. So here the thickness measured is 1177 angstroms, which is pretty close to the standard value of 1155 angstroms. Standard, which is 2200 angstroms thick. So I'm going to place this sample and make a quick calculation. I'm using the same routine, 211. So this standard is almost equal to the order thickness, which is 2825. So this is less than 2825, so the unit will display the actual thickness. So the calculated thickness is 2222, which tallies with the standard thickness here. I'm going to change the sample to another standard. These standards are for our internal testing. They will not be included with the system. I'm going to select a silicon nitride sample, which is about 1000 angstroms in thickness. So this sample calls for entering a refractive index. So I'm going to select program 211, enter, and the refractive index of silicon nitride film is 2.000. The calculated thickness is 968 angstroms, and it tallies with the standard value here. I'm going to measure a thickness which is less than 1000 angstroms. So in this one, the film thickness is about 434 angstroms. The details of various measurement routines and calculation routines are given in the user's manual. This measurement shows that the thickness is about 514 angstroms, which tallies with the film. I have a silicon dioxide film which is 9,400 angstroms thickness, and so during the regular operations, it should be always made sure that the table is clean, free of any dust particles. And also, the unit should be mounted on a vibration-free table, and the unit requires a warm-up time of about 10 to 15 minutes in order for the laser to stabilize. Now the TL is 1013 angstroms. Now, since it is expected thickness is above 9000 angstroms, we have to calculate using the formula that TL plus N times 2825, which is the auto thickness, and I'm going to add 1013. So So by using the formula where the constant value I have used as 3, I'm able to get the actual measurement thickness of 9,488 angstroms. Use the system to measure the user samples. Here is a aluminum oxide sample, Al2O3 on silicon substrate. I'm going to make sure the system is properly aligned. So I'm going to use the same program routine 211, but here I'm going to enter the refractive index for the aluminum oxide as 1.637. It is very important to enter the refractive index closer to the value for a wavelength of 632.8 nanometers. Which is helium neon laser wavelength. So the system measured value thickness is 187 angstroms and the fixed refractive index is 1.637. The order thickness is 2360. I'm going to change the sample now to a zinc oxide sample and take a measurement. So the refractive index for this sample is 1.924. So this sample measured thickness is 634 angstroms. I'm going to use a different measurement routine and see how it does. So by selecting the proper routines, it is possible to enter various values for the substrate refractive index and optical extinction constant, and create a user-definable recipe for this system. This system is based on Intel CPU, and it is very useful. So this particular measurement with a different measurement routine did not give a reading closer to the expected value. This one measures 352 angstroms. So the correct process for this is 211. Now I'm going to test the third sample I have, which is a Carlene sample. These samples are being used only to demonstrate that this system is capable enough to measure the film thicknesses. I'm going to use the program again, 211, and enter the refractive index 1.639. The standards I used are silicon dioxide films on silicon samples, and they are original Rudolph standards, NIST traceability, available details, and this ellipsometer should be always verified periodically with the standards in order to make sure the system is performing within the limits. So this one, the film expected thickness is 2500 angstroms, but instead it is showing you order thickness of 2356 and TL713, and if I assume that the order thickness plus the TL713 is to be computed, it measures about 3069 angstroms, which is about 500 angstroms above the measured desired value. I'm going to select program routine 111 and see how it does. So in order to evaluate this system, various standards should be used, at least 2 or 3, and verify that the unit is performing correctly. So with this program routine 111 on a Carlene film, I get a measured value. The order thickness is 2356 again, but the TL is 371. So I'm going to calculate. And the measured thickness is 2727 angstroms. And I'm going to repeat this and see if the program or the system measures the same value. Just by hitting the continue, the same program is selected again. So the unit now this time displaying 374, and The calculated thickness is 2730 angstrom.